Hi, we're going to look at the question from the NSC supplementary exam, May-June 2024. It's a question on a parabola and a straight line. And the question reads, the graphs of f of x, which is equal to x squared minus 2x minus 3. If we stop and inspect the parabola question, or the parabola function given, we see that and look at the graph, the constant is minus 3, which immediately tells me that my point P, which I can put in the graph right now, is minus 3. Okay, we also know that we can find the x-intercepts by letting y to be equal to 0. We can find the turning point, which we can use calculus for. But we're going to stop there. And then we go to the next function, g of x equal to mx plus c. So if we look at the graph, the straight line, we already know that the y-intercept is minus 3. So immediately I know that the c value there is minus 3. And we carry on to read, d and e are x-intercepts, and p is the y-intercept of f. The turning point t is 1 minus 4. So I'm going to put that down as it is given. The graphs of f and g intersect, points of intersection. If ever you're finding point of intersections, you just equate both the equations. So we get on to the first question. It says write down the range of f. Now we know in any parabola question, the range, in this case because it is a smiling face, would be y greater and equal to the y value of the turning point, which in this case is minus 4. So there's our first one, y greater and equal to minus 4. The second question says determine the coordinates of D and E. Now if we look at the mark scheme there, it's a 3-mark question, so we've got to do some work. Now looking at the actual graph, D and E are the x-intercepts, and all we do is let the equation be equal to 0. Let y be equal to 0. So if we take x squared minus 2x minus 3, we're going to equate to 0. We are going to factorize that. And the factors for that equation would be x minus 3 into x plus 1, which solves to x to be 3 or x to be negative 1. And you can see from the graph, 3 being positive means that E would be 3 and D would be minus 1. The question said coordinates, so we need to write in coordinate form. And we're going to say E is the point 3, 0. And we got D to be the point minus 1, 0. And there we have our E and D. Moving on to the next question. Just want to clear my screen a little. It says determine the equation of G. Now we know that G is the straight line. And to work out the equation of a straight line, we need the M and C. Okay, but remember initially I said we know that the C value is minus 3. So we can quickly put it into G of x, which is equal to mx plus c, which is negative 3. Now we can do it two ways. Remember, this is the same as saying y is equal to mx minus 3. We could actually sub a point to find m, or we could use the gradient formula and use your y2 minus y1. I'm actually going to go with a substitution, or you could actually find it with the formula as I said. So we do have options here. So what I want to do is, if I take any point on the graph, I'm going to take E. E is a point 3, 0, which is your x and y. And your y value is 0 into m. And then we get 3m is equal to 3, and therefore m is equal to 1. And therefore our g of x equation will become mx, which is 1x, plus c, which is a negative 3. So we get y is equal to x minus 3. You could have looked at it at a distance from e to, so we're going down, so it should be negative, and 3 over 3 is 1. And that could work out using your y2 minus y1 over x2 minus x1 formula. Okay, we're going to go to the next question. Give you some time to read as I erase the screens. Okay, we may need some of the previous answers to help us going forward, so please keep that written down. So the next question that we are reading is 6.4, which says write down the values of x for which the distance between both the graphs is greater than 0. So I think an easy way to actually work with this is just to take g of x on the other side, and the question would now read, when is f of x, we take minus g of x on the side, is greater than g of x. So we're comparing both the graphs, and greater normally would mean when is f above the g graph. So to do that, I'm going to actually go to the graph and use my highlighter. So we'll notice that at the points where they intersect at the point E, you'll notice from that point f is above g. So there's my first answer that I want to write down. So that's actually x greater than 3. You can write it in interval notation, which will be from 3 going to infinity. In other words, x is an element from 3 to infinity. We cannot include 3. There's no equal to sign, and we cannot include infinity. So that's our first one. So on inspection of the graph, you'll notice from the point P that f is also above. And if we're looking at the answer from the point P, remember, don't get caught out with minus 3. We want the x value. So the x value there at P is actually 0. So it's from 0 going to negative infinity, which we could write down as x less than 0. Or in interval notation, remember we're going to minus infinity on that side. So x is an element of minus infinity to 0. And there we have our two answers. Okay, we're looking at the next question, which now is 6.5. Let's quickly zoom into 6.5. It says, determine the maximum. Now remember, we can use our calculus. Maximum vertical distance is to find your derivative and equate to 0. But before we go there, determine the maximum vertical distance between h and g. Now if you look at the top, the graphs given is f and g. So we know g. But we don't know h. But then they tell us that h is the negative of f of x. So if we take the graph of f of x, which we have, as you can see, that's a given equation, which is equal to x squared minus 2x minus 3. Now they are telling us that h of x is the negative of this. So all we're going to do is change all the signs here to produce the h graph, which is basically a reflection of the f graph. But even if we don't know that, we're just changing all the signs. And then the question says, determine the maximum vertical distance between h and g. So all we're going to do is take h and we're going to minus g. Now we know h is minus x squared plus 2x plus 3. In the previous question, we did find out the g of x, and the g of x, if I remember, was x minus 3. Now we're going to subtract that. Okay, so if we actually subtract the g of x, your signs are going to change. You're going to have a minus x minus 3. So let's give it a name. Let's call this, which I haven't done, D for distance, all right? And then we have D will be equal to, working with your like terms, you're going to have a minus x squared, 2x, and a minus x will give me a plus x. And 3 minus 3 will actually cancel off to 0. In other words, 3 minus 3 is 0. Actually, I did make a mistake there in changing the signs. Minus x, that should become a plus 3. And that'll give you a plus 6. Now remember the question is saying find the maximum vertical distance. So all you got to do is find the derivative, which will be minus 2x plus 1. And then you can equate that to 0. And then you got minus 2x is equal to minus 1. Dividing by negative 2, you're going to get x to be half. But the question was to find the maximum vertical distance. So at x equal to half, we have the maximum distance. The actual maximum distance, we need to sub x back into the distance formula. So d is equal to, your distance formula is saying minus x squared plus x plus 6. And then all I'm going to do now is substitute the half. And if you substitute the half with your calculator, you're going to get a maximum distance of 25 over 4 or 6.25. And that is the maximum vertical distance between both the graphs. Let's read the next question. Give you some time to read. Okay, we're going to the next question, which I'm sure you read by now. And the question says, given that g of x, that k of x is equal to g of x minus n. So let's quickly find k of x before we go on. K of x is equal to g of x, which we found in the previous question, which was x minus 3. And then they're saying minus n. That's k of x. Now they say determine n if k is a tangent to f. So if you actually think about n that we're trying to find in this context, we want to move that line such that we have the straight line touching this parabola only once. So if we look at the question, what do we know? Okay, remember n is a constant here. So we know that the gradient of k of x is actually equal to 1. But we know that if this graph is a tangent to the parabola, then if we find the derivative of the parabola, it's actually, the derivative is a gradient at a point. So we know m is equal to f prime of x, right? And if we find the derivative of f prime of x, which is your gradient, which will be 2x minus 2. Now we know the gradient is already 1. So we want to find out at what x value is the gradient equal to 1. So we're going to equate. The gradient is 2x minus 2, the f prime of x, which is actually equal to 1. Because that will be the gradient of the tangent, which we pick up from the equation. And if we solve for x, we would get x is equal to 3 over 2. So we know that the point of contact where the tangent, where the straight line is the tangent to the graph, would be at a point 3 over 2. Now we can find the y value. And to find the y value, we're going to sub 3 over 2 into the f of x equation, which you can use your calculator. So you're going to take 3 over 2 and put into f of x, which is equal to x squared minus 2x minus 3. You're actually finding, just going to write that down for you, f of x is equal to x squared minus 2x minus 3. And using your calculator, you're going to put in f of 3 over 2. And if you actually work that out, the calculator will give you minus 15 over 4. Okay, which could be minus 3.75. So we know that the point of contact is 3 over 2 minus 15 over 4. That's the point where the tangent and the parabola actually meet. So now let's get back to the question. Now the question wants us to find out what is n. Okay, so we have our point of contact, which we can write down. And that point of contact we found out was 3 over 2 negative 15 over 4. Remember now that this is your x, y value. Now we know that the equation of k of x is x minus 3 minus n is equal to, and we already know in this case, all right, that the equation that we are using, okay, x minus 3 minus n, as I was writing, is actually equal to k of x. Now I just want to put the y on that side. Remember that your k of x represents y. So all we're going to do is sub that point because it's on the k of x graph. The x value is 3 over 2 minus 3 minus n, and the y value is minus 15 over 4. And then we're going to solve for this. Take minus n onto the right, becomes a plus n, and then we got 3 over 2 minus 3 plus 15 over 4. And if we actually work that out with a calculator, we will get an n value of 9 over 4. Or we could say n is equal to 2.25. And that is how we work out the value of n. Thank you.